This is VCAA 2011 question 1. Well, we're doing question 1 and 2. Actually, we'll leave 3 for the next slide, but there's a tractor. It has a mass of 500 kilograms, towing a trailer of mass 2,000 kilograms, and the tractor and trailer are accelerating at 0.5 meters per second squared. And that's a key point there. And what we're going to do is look at this tractor and trailer system that's all accelerating at 0.5 meters per second squared. And we're going to think about that system when we answer these questions. So let's redraw that. We'll make it as simple as we can. So we have a tractor and a trailer, and that's a whole system. And that whole system is accelerating at 0.5 meters per second. The first question is, what's the magnitude of the net force? So there's a net force here on the system. And when you do net forces, you're basically looking at all the forces on the system. And the only forces on this system is the accelerating system that is probably being driven by the tractor. There aren't any friction forces. Have a look at the question here. Ignore any retarding friction forces. Ignore the mass of the towing rope, and they're starting from rest. So we have this system and it's accelerating, and the only force on it really is the driving force of the tractor. We can think of this system really as just being one mass accelerating. Those two things are really equivalent. So the net force, according to Newton's second law of an accelerating system, is equal to ma. But the mass of this system is the mass of the tractor, which is 500 kilograms, and the trailer, which is 2,000. So really there's 2,500 kilograms of mass. It's accelerating at 0.5 meter per second squared. So our total magnitude of the net force is 1,250 newtons. Now we're looking at the tension, and what we can do about the tension in the rope, which is here, is just focus on the trailer. So we have this 2,000 kilogram trailer, and there's a tension applied to it. So the net force, and in this case we're not using the net force on the system but just on the trailer. And the only forces on the trailer really is the tension in the rope. And that, according to Newton's second law, is equal to ma. So the tension is the mass of the trailer, because here we're only interested in the net forces on the trailer. So the mass is the mass of the trailer. The trailer is still accelerating at 0.5 meters per second squared, so the tension is 1,000 newtons.